Hello, everyone. So the very top of this assignment, block 2, assignment number 3, is your homework. Towards the end, which we are scrolling to, is your notes that are going to be attached to your homework. So I just wanted to go over some things about solving absolute value inequalities graphically and algebraically. The 4 problems I'm about to show you are absolute value functions and linear functions that are already graphed. I just want you to see if you can figure out what the solutions are. So notice that the absolute value function in red and the linear inequality in blue that are graphed, the first thing you want to do is ask, where do they intersect? Okay. Here I notice that they intersect at these 2 points, which happen to be at 0, 5 and at 2, 5. That means x equals 0 and x equals 2. However, I'm looking at where the shading is. Where the shading is where it's true for both the absolute value function and the linear inequality. I notice it's true when these absolute value, the arms on these absolute values, notice that's above the linear inequality. Those absolute value functions that are sticking up, that is where it's true. And I notice that those arms that I highlighted in yellow are going away from each other. They're not touching each other. Okay, so since these arms are going away from each other, it's the same thing as on a number line when you have them going to the right and when you have them going to the left. They're not touching each other. Now, the reason why I drew an open circle instead of a closed circle is I noticed that it happens to be a dotted line. So dotted means open circles, right? If it has a closed, like a solid line, it's going to be a closed circle. And because it's an open circle or dotted line, and they're going away from each other, we're going to use the word or. So I still have x, and I still have 0, and I still have x, and I still have 2 with the word or in between. But now what I'm going to do is I'm going to make sure that I draw those inequalities. So see how on the left I have this yellow open circle pointing to the left? That's less than, because it's pointing to the left. Notice that my black little symbol is pointing to the left, right? My black inequality. And I have an open circle going to the right, so I'm going to have a greater than symbol. So my answer is x is less than 0 or x is greater than 2. So let's take a look at the next one. I have the exact same blue inequality and I have the exact same red absolute value. The difference is that I notice that it's no longer a dotted line, now it's a solid line. And solid means that it's closed, right? Closed is where you have like less than or equal or greater than or equal. Okay. The other thing I notice is that the shading is going down. So where is it true for both the absolute value inequality and the linear function? Notice it's this V part that I'm highlighting underneath. Do you see how that those 2 yellow pieces that I highlighted are touching each other? They look like this that I'm drawing. See how they're touching each other? If I were to flatten them out, it would look like this. Those 2 pieces are still touching each other. They're just flat now. When they're going apart, like the first one, it is an or problem. But when they're going together, it is an and problem. So I'm going to have the exact same solution since it's the exact same sketch of the absolute value and linear inequality, just going different directions. See right here, I'm still going to have x is 0 and x is 2. So I'm going to put x is 0 and x is 2. The difference is that I want my arrows to go together because that V, those two yellow pieces that I highlighted, are going together. And if they're going together, that means the arrows have to face each other. So x is less than 0 and x is less than 2. Actually, I think I might have accidentally said that wrong. I meant x is greater than 0 and x is less than 2. See how those two inequalities are pointing together? So let's take a look at the next drawing. So on the next drawing, I have my red absolute value function and I have my blue linear inequality. And I notice this time that the entire absolute function is shaded. Notice the entire absolute value function is completely covered in blue. Okay. Now, the difference between that one on the left and the one on the bottom right is this absolute value function on the right is not shaded at all. Nothing is colored, nothing is highlighted, right? So nothing colored. I didn't write that very good. Let me try to write that a little better here. So nothing is shaded on the one on the bottom right. The one on the bottom left is everything is shaded. So I want you to think, how would you describe something as everything is colored, everything is shaded, versus how would you describe it if nothing is shaded? Okay, well, when everything is shaded, we call that all real numbers. Or sometimes we call that infinitely many solutions. On the right, nothing is shaded. So when nothing is shaded, what do I call that? That's called no solutions. And I apologize if you happen to hear my mother in the background asking my son a question. Okay. All right, so we're going to use that information and what we did in class to see if we can solve these absolute value inequalities by graphing and algebraically. So the first thing I want to do is I want to take a look at the left side versus the right side. The left side right here is an absolute value function. So I'm going to call that absolute value function f of x equals the absolute value of negative 2x plus 6 minus 4. And I have my linear inequality. So my linear inequality is g of x is greater than or equal to 4. All right, now in order to graph the f of x, the absolute value function, it's really important that you rewrite it. You can't have a number in front of the x. So I need to figure out how to get rid of this negative 2 that is multiplying to the x. Well, to get rid of a negative 2 that's multiplying, you have to divide. So I'm going to divide by negative 2. Divide means to factor, right? Factor or divide by negative 2. So when I take negative 2x divided by negative 2, I'm left with x. And 6 divided by negative 2, I'm left with negative 3. Now again, I can't have this -2 inside the absolute value. I have to take that -2 out. When you take the absolute value of -2, it becomes +2. So now I have 2 times the absolute value of x minus 3 minus 4. So where is the vertex on my absolute value function? Remember, it's the opposite of the inside. Keep the outside. So it's 3 comma -4. So I'm going to go write 3 down. 1, 2, 3, 4. And what is that that +2 over 1 telling you to do? It's telling you to go up 2, right and left 1. So up 1, 2, right and left 1, up 1, 2, right 1, up 1, 2, right 1, up 1, 2, right 1. And on the left, up 1, 2, left 1, up 1, 2, left 1, up 1, 2, left 1. So how do you know how far to go? Basically, what you have to do is you want to make sure that you go up enough that you can kind of see a very much a picture instead of just kind of eyeballing it, right? You want to have a very accurate picture. So let's take a look now on the right. Okay, the g of x is greater than or equal to 4. What does that mean? That means if y is greater than or equal to 4, then I'm going to go on the y-axis 1, 2, 3 to 4. And I want to draw a line straight right, straight left. And this greater than symbol, that means that I want to shade above. Okay, so I'm going to shade above the line. So again, make sure the greater than or equal means to shade on the line and above the line, right? So on and above the line. So where does the absolute value function and the linear inequality, where do they intersect at? Well, it looks like to me that they intersect at -1, 4. So x equals -1. And it looks like they intersect at 1, 2, 3, 4, 5, 6, 7, 4. So x equals 7. Now you notice those two pieces that are highlighted, right? I'm going to highlight them a little bit more. Notice those two pieces are going away from each other. And since those two pieces are going away from each other, this is an OR problem. Since those two pieces are going away from each other, this is an OR problem. And because those two pieces are going away from each other, notice those arrows are going away from each other, then when I write my inequalities, those arrows have to go away from each other also. So x is less than -1, or x is greater than 7. Now I'm going to put an equal symbol on both of these, and the reason why I'm going to put an equal symbol on both of these is because the original problem right here has an equal symbol as well. It's a greater than or equal. Now I want to do the exact same problem, but instead of graphically, I want to do it algebraically. So let me see if I can move this down a little bit. All right. I'm going to write this problem again. This time I'm going to do it algebraically. So the absolute value of -2x plus 6 minus 4 is greater than or equal to 4. So just like we did in class, when it came to solving, the first thing that you want to do is you want to isolate. You want to get the absolute value by itself. So whatever's adding or subtracting, you want to get rid of first. Whatever's multiplying or dividing, you want to get rid of second. Well, in this case, this 4 is subtracting to the absolute value. So to get rid of it, I want to add it. And when I add 4 to both sides, I get the absolute value of negative 2x plus 6 is greater than or equal to 8. So now what I want to do is I get my absolute value by itself. Now I want to write 2 equations. So that's step number 2 is write your 2 inequalities. So 1 always stays exactly the same. So negative 2x plus 6 is greater than or equal to positive 8. It stays exactly the same. And be very careful on this one. 1 where the outside becomes the opposite. So it'd be negative 2x plus 6. That's inside. But the opposite of the outside, instead of greater than or equal to 8, becomes less than or equal to negative 8. And the very last step, what I want to do is I want to solve. And so if I solve, I would subtract 6. So negative 2x is less than or equal to negative 14. And I divide by negative 2. And be very careful. So I'm going to put a star next to this. Anytime you divide by a negative, multiply or divide by a negative, you have to flip the inequality because dividing or multiplying by a negative means to do the opposite. So instead of less than or equal, it's greater than or equal. And negative 14 divided by negative 2 is 7. On the negative 2x plus 6 is greater than or equal to 8, you subtract 6 also. So negative 2x is greater than or equal to 2. And when you divide by negative 2, so again, anytime I multiply or divide by a negative, you flip the inequality. So x will now be less than or equal to 1. So how would that look like on a number line? So you can get an idea, is this an or problem or an and problem? You always put the smaller number on the left. Notice the smaller number is 1. These are closed circles because of the equal. Anytime you have an equal, it's a closed circle. On the 1, it's pointing to the left. And on the 7, notice the arrows pointing to the right. And because they're going away from each other, that is an and problem. So when they go away, remember they're not an or problem. When they're going away from each other, it's an or problem. When they're going towards each other, it's an and problem. So let's take a look at the next problem, which is negative 2/3 times the absolute value of 4x plus 2 is less than or equal to 6. So I want to get an idea what this looks like graphically and algebraically. So I'm going to go ahead and graph this. I'm going to graph my left side, which is my absolute value function. So that's f of x equals negative 2/3 times the absolute value of 4x plus 2. And of course, I want to graph my linear inequality, which is g of x is less than or equal to 6. Now, no one said you had to graph the absolute value function first. You can graph the linear function first. So I'm going to go ahead and do the y is less than or equal to 6. That means I'm going to go to 6 on the y-axis, 1, 2, 3, 4, 5, 6. And I'm going to draw a line straight right, straight left. And because it's less than or equal, that means I can shade on the line or anything below the line. So let's make sure that we write that. So less than or equal means to shade can't wait to find my pen so I can write better. So shade on and below the line. Okay. So now I want to graph my absolute value function, but before I could do that, I have to rewrite it because notice it's 4x plus 2. I can have an x plus something, or I can have an x minus something, but I definitely cannot have a 4 in front of it. So I want to figure out, what do I have to do to rewrite this? Well, I got to get rid of that 4 that's multiplying to x. Well, to get rid of a 4 multiplying to x, I'm going to divide by 4. So when I divide by 4, then what am I going to be left with? Well, 4 divided by 4 is 1, so I'm left with 1x. And then I'm left with 2 divided by 4, and yes, I know it's half. I'll take care of that in a minute. I still have this negative 2/3 in front. Now again, I can't have this 4 inside, so I'm going to take the absolute value of it and stick it on the outside. So I still have a negative 2/3 on the outside, but the absolute value of 4 is 4. And I'm going to go ahead and reduce that 2 over 4 to 1/2. So any numbers that I have outside are multiplying. So negative 2/3 times 4 happens to be negative 8/3. So negative 8/3 times the absolute value of x plus half. So I want to know, where is my vertex? Well, it's the opposite of the inside. Keep the outside. So my vertex is negative 1/2, 0. And my a, which is a number in front of the absolute value, is negative 8/3. And that means since it's negative 8, I go down 8. And the 3 tells you how many spaces to go right and left. So I'm going to start at my vertex, which is negative 1/2, 0. And then I'm going to go from that point down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And then I'm going to go back to the middle and I'm going to go left 1, 2, 3. And so it looks something like this. Sorry, it's a little off. It's my pen. I'm on a hunt to find where my actual laptop pen is. So what do you notice about this? Do you notice that everything in the absolute value function is shaded? So again, everything is shaded, right? And when everything is shaded, what do we write for an answer? We write all real numbers, or sometimes you'll see it as infinitely many solutions. So again, all real numbers or infinitely many solutions. I've seen it both ways and I want to show it to you. That way you're fully aware of it, okay? So how do I figure out that algebraically? So I'm going to go ahead and do this problem now that I did it graphically. I'm going to do it algebraically so you can take a look at this. So negative 2/3 times the absolute value of 4x plus 2 is less than or equal to 6. So remember that the first thing you always do is you want to get the absolute value by itself. So whatever's adding or subtracting, you want to get rid of first. Whatever's multiplying or dividing, you want to get rid of second. Well, there's nothing or adding or subtracting to the absolute value, so we don't have to do that. But what's multiplying or dividing? Well, that negative 2/3 is multiplying. So to get rid of it, I want to multiply by its reciprocal. It's the same thing as dividing by negative 2/3 is multiplying by negative 3/2. And so now I'm left with the absolute value of 4x plus 2 is less than or equal. And when you multiply the numerator with the numerator. So 6 times negative 3 is negative 18. And the denominator with the denominator. 1 times 2 is 2. Okay, negative 18 divided by 2 is negative 9. All right, now in class, we talked about what happens when an absolute value equals a negative. So I want to make sure that we put a big, bold star on this. Okay, so when the absolute value equals a negative number, it's automatically no solution. That's when it's an equal. This is not an equal problem. This is a less than or equal. So when the absolute value is less than or greater than a negative number, we get either a no solution or an infinitely many solutions. So how do you know which one it is? So I want you to think about it really quickly. When you take an absolute value, what kind of answers are you always going to get? Okay. So again, when you take an absolute value of a number, what kind of answers are you always going to get? So for example, the absolute value of 2 is 2. The absolute value of negative 3 is 3. The absolute value of 0 is 0. What do you notice about the answers? They're positive. Will your answers ever be negative? The answer to that is no. So when is an absolute value greater than or equal to a negative number? And the answer to that is always. And because it's always, an absolute value is always greater than or equal to negative, our answer is infinitely many solutions. Or you can put all real numbers. So either one. So all real numbers or infinitely many solutions. So let's take a look at the next one. The next one being number 3. So in this case, we have an absolute value of, right, is greater than 2. So negative 3 times the absolute value of 1 minus 1/3 x plus 5 is greater than 2. So I'm going to go ahead and I want to graph my absolute value function. I want to graph my linear inequality. So I'm going to go ahead and do the linear inequality first, just because I think it's easier. So g of x is greater than 2. So that means you go to 2 on the y-axis. Okay. But instead of a solid line, I'm going to draw a dotted line because there's no equal, right? It's just greater than. And I'm going to shade above. So this is going to be a dotted, right? And shade above the line. I'm so sorry that it's written so poorly here. I think I'm going to have to go buy a new laptop pen if I can't find my new one. So let's take a look at our absolute value function. So negative 3 times the absolute value of 1 minus 1/3 x plus 5. So the first thing I notice about that is that it doesn't have an x first inside. Okay, it should always go x first. So not the number, an x. So I need to make sure that I take care of that. So I'm not changing the signs. All I'm doing is just flip-flopping spaces. So instead of positive 1 minus 1/3 x, all I'm doing is I'm just writing it as negative 1/3 x plus 1. Then I notice I can't have a negative 1/3 in front of that x. I can have an x plus something or an x minus something, but definitely not a negative 1/3. So I need to get rid of that negative 1/3 by dividing, right? So outside I still have a negative 3 and a positive 5 behind the absolute value. But again, I want to divide this negative 1/3. Dividing by a fraction is the same thing as multiplying, okay? So making sure you realize dividing by negative 1/3 is the same as multiplying by 3. So if I were to multiply by negative 3, onto both of them, so negative 1/3 times negative 3 is 1, so I'm left with 1x. 1 times negative 3 is negative 3. So I'm still left with a negative 3 on the outside, but again, I can't have this negative 1/3 in here. So I'm going to take it out. And remember, I'm taking the absolute value of negative 1/3. So when I take the absolute value of negative 1/3, it becomes positive 1/3. And I'm still left with the absolute value with x minus 3 inside and a plus 5 outside. So anything on the outside multiplies, right? This is like negative 3 over 1 times 1/3. So when you multiply the numerator with the numerator and the denominator with the denominator. So you get negative 3 over 3, which is just negative 1. So negative 1 times the absolute value of x minus 3 plus 5. So where's our vertex? It's always the opposite of the inside. Keep the outside, so it's 3, 5. And our A is negative 1 over 1, which means we're going to go down 1, right and left 1. So I'm going to go to 3, 5 first. So 1, 2, 3, 1, 2, 3, 4, 5. And then from there, I'm going to go down 1, right and left 1. So it looks something like this. Okay. So what do I notice? The part of the absolute value that's shaded is this part that's above this V. Do you see how those two pieces are touching each other, right? Those two pieces are touching each other. They kind of look like this. Like if I were to flatten that V out, it would be like a flat plank. Anytime the two pieces touch each other, it's automatically an and problem. So I know this is an and problem when they're touching each other. So where do they intersect at? Well, it looks like they intersect right here at 0, 0. So x equals 0. And 1, 2, 3, 4, 5, 6. It looks like they intersect at 6, 0. So x equals 6. Now, because they're going together, I'm going to put x is 0, x is 6. I need to make sure my arrows are pointing together because it's an and problem. X is greater than 0 and x is less than 6. And I'm going to go back and double check. There's no equal sign underneath in the problem, so there's no equal sign here. So x is greater than 0 and x is less than 6. So how do I show this problem algebraically? So negative 3 times the absolute value of 1 minus 1/3 x plus 5 is greater than 2. So we always want to get the absolute value by itself. So whatever is adding or subtracting, I need to get rid of first. So I want to subtract 5. And then I want to divide by negative 3. And be very careful. I'm multiplying or dividing by a negative. Anytime I multiply or divide by a negative, I flip the inequality. So 1 minus 1/3 x is less than 1. And then I'm going to write my two equations. 1 minus 1/3 x is less than 1. 1 minus 1/3 x is greater than negative 1. So notice that 1 stays the same and 1 is the opposite. So if I were to solve for x, and I kind of ran out of room, So I apologize, I'm gonna have to move it over here. I would subtract 1. So negative 1/3 x is greater than negative 2. And I'm going to multiply by the reciprocal. When I multiply by the reciprocal, remember I'm multiplying by a negative, x is less than 6. And here, when I subtract 1, I get negative 1/3 x is less than 0. And when I multiply by a reciprocal to solve for x, I get x is greater than 0, because again, you have to make sure that when you multiply and divide by a negative, you flip the inequality. So, which of the two numbers is smaller? 0 is smaller than 6. They both are open circles. On the 0, you're pointing to the right, and on the 6, you're pointing to the left. So you see how they're going together? So that's the reason why we write our answer, x is greater than 0. And x is less than 6. I hope this was helpful. Have a good day.